Good morning, afternoon, or evening. Delete as appropriate. Today we're going to combine two lessons, Powers of 10 and Scientific Notation, together, and our objective is to introduce number and word notation for large numbers and exponential notation for powers of 10, and to introduce scientific notation. So a bunch of different notations, but they all are connected to each other. Okay. So what I would like to do would be to take a second and think about three numbers, and it would be these three numbers. Let me just make sure I'm okay. We're good to go. 100. What about 1,000 and 1,000,000? Okay. So let's think of different names we can come up with for each of these. So, normally in class I would have you guys come up with the names, but, since I'm not, talking, you can think of them as you come up. If you write different ones in your boxes, or you can come up with different names that I would come up with. But, let's start with something basic. 100. Another way to write 100 would be simply 10 times 10. Would be another way to write 100. What about 1,000 divided by 10? Yeah, just as good. What about, we wrote it this way, 300 minus 200. Same thing as 100. You can also do 10 squared. And last, you can just do 1 and the word 100. What about a different way to say 1,000? Okay, let's start with the basic. 10 times 100. Oop, not 10 times 1,000. 10 times 100. Okay. Another way to do it would be 3,000 divided by 3 is the same thing. Okay. Or 500 plus 500. Or 10 cubed, 10 to the power of 3, or just 1,000. These are all different ways of naming the same thing of 1,000. Okay, last but not least, 1,000,000. 10 times 100,000 would be one way to do it. 2,000,000 times 1/2, and I apologize for going over the box. 2,000,000 times 1/2 is the same thing as 2,000,000 divided by 2. Okay, you could write it 10 to the power of 6, or 1 and the word million. Okay, so that you can come up with hundreds of different ways of renaming those three numbers. But you notice that you can use different operations, you can use exponents, you can use numbers and words. And that's one of the things that we want to focus on as well right now, number-word notation. Okay. Woo! Mr. Shanto, getting all crazy there. Zoom. Okay. Number-word notation. Number-word notation is commonly used to express large numbers with one numeral and one word. So if you're talking about, when you're talking about the stock market, they talk about hundreds of millions and billions of shares traded in a particular day. They aren't going to say, or if you're talking about the national deficit, when you're talking about trillions of dollars, you don't want to having to write all those zeros. So say you're talking about something that has 25 billion. You don't want to have a way, you don't want to have to write all of those zeros over and over and over again, okay? This would be what kind of notation? This is standard. Remember that from the last lesson. This is standard notation. Okay? So what is a different way that we could do this? Well, we could write, let me move over a little bit, 25 billion as 25 times 1 billion. Need a little bit more space. Okay. Which is the same thing as 25 billion. Okay, that's not any simpler, obviously. But what about this? 25. And then instead of saying 1 billion, we just said billion when we write it. Okay, that's a lot easier. But that's not where we're going to stop. Okay? But that's just number word notation. So this is your numeral. So you wrote number word notation with one numeral, 25, and one word, billion. So 25 billion. Okay? So let's look at a place value chart. Okay, so here's our place value chart with powers of 10. So as you can see, we start from, let me zoom in a little bit so it's easier to see this. You start from just the basic 10. You know, what's the product of 10 is 10. And exponential notation is 10 to the power of 1 is just 10. Okay, so that's itself. It's basically 10 times 1 or whatever. Okay, 100 is the same thing as 10 times 10, which is 10 to the power of 2. 1,000, and here's our number word notation. We have the number 1 followed by the word thousand. 10 times 10 times 10. 10 to the power of 3. And so on. 1 million is 10 times 10 times 10 times 10 times 10 times 10. 10 to the power of 6. 1 billion. 10 times 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 10. So 10 to the power of 9. Okay? So we have lots of different ways we can write it. So standard notation is just the numbers right here. This is number word notation. Here's writing it as products. And then more simply, this is the last column, our exponential notation. That's the simplest way to do it. Now, one thing you need to notice is when we talked about standard notation, we talked about separating groups of numbers with commas, and then each group has 3 numbers. Well, each one of these groups has a name. It's called a period, and I kind of mentioned that briefly yesterday. So this group of 3 numbers in 1 billion is 1 period, which is the ones, tens, and hundreds. The second group is the thousands period. The third group is the millions period. Okay, so the three groups of zeros are different periods. Okay, but they're grouped in things called periods. So 1 billion has 3 periods, which is 9 zeros. So if you notice, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros in 1 billion. Our exponential notation is 10 to the power of 9. So when we're writing our powers of 10, all we need to do is look at the exponent to know how many zeros we're going to have. 3, 6, 9 for 10 to the power of 10, which is 1 billion. Okay? So can we make a guess then what 1 trillion will look like? How many zeros will 1 trillion have? Well, if each period has 3 zeros, and 1,000 is 1 period, million is 2 periods, billion is 3 periods, then I'm going to have for 1 trillion 4 periods. So there's 4 periods. And how many zeros? There's 12 zeros. Okay? So for 1 trillion, how many times am I multiplying 10? Well, since I have 12 zeros, I'm multiplying it 12 times. So each period has 3 digits. 1 trillion has 3 digits times 4 periods or 12 zeros. So you can start thinking about bigger and bigger and bigger numbers. Once you get past trillions, you go to quadrillions. So let me write that. Let's go over here. So after our billions, we have trillion. After trillion, we have quadrillion. And we have quintillion. So we can start following the same pattern for the next for the periods that follow billion. Okay. Okay, so what are we going to do with this, Mr. Shanto? Why is this so important? Well, again, I mentioned that you could use it to talk about the national deficit. You could use it to talk about money for the stock market and such like that. Scientists are also, want to use it when they're talking about miles. So if you're talking about planets or a distance in space, you're not talking about, 200,000 miles, 300,000 miles. You're talking about much greater distances than that. You're talking about a lot of space, a lot of distance to travel. So that's why we're going to introduce this concept called scientific notation. But let's kind of look at our powers of 10 first. So if we're talking about, and I promise I will use a darker color today, so yellow is not a good thing on a white background, so we'll use black today. 10 to the power of 2 is the same thing as 10 times 10, which is the same thing as 100. 10 to the power of 3 equals 10 times 10 times 10, which is the same thing as 1,000. So 10 to the power of 4 is the same thing as 10 times 10 times 10 times 10, which is the same thing as, Mr. Shanto, I'm getting ahead of myself here. 40,000. 10 to the power of 5, 10 times 10 times 10 times 10 times 10 times 10, 500,000. And last but not least, 10 times, 10 times 10 times 10. That's 4. Let's get 5 tens, and we have 6 tens. We have 6. Where did I get? Mr. Shanto, what are you doing? I apologize, ladies and gentlemen. I was thinking numbers. I was thinking exponents, and I wrote the numbers when I'm supposed to actually just be multiplying 10. The first one was 10,000. Second one was 100,000. Third one is 1 million. Okay. Again, notice 10 to the power of 6. I have 6 zeros. 10 to the power of 5. 5 zeros. 10 to the power of 4. 4 zeros. Okay. Now we can move down to the one below where we have 2 times 10 to the power of 2 is the same thing as 2 times 10, which equals, 2 times 100, which equals 200. So for 3 times 10 to the power of 3, 10 to the power of 3 is the same thing as 1,000. So 10 to the power of 3 equals, 3 times 10 to the power of 3 equals 3,000. Okay, same thing. 4 times 10 to the power of 4. 4 times 10 to the power of 4 is 10,000. So 4 times 10 to the power of 4 is 40,000. 6 times 10 to the power of 5. All right. Apologize for the interruption. 6 times 10 to the power of 5. So I have 6 times 10. 10 to the power of 5 is the same thing as 1 with 5 zeros, 100,000. So 6 times 100,000 is 600,000. 8 times 10 to the power of 6. So we have 8. 10 to the power of 6 is 1 with 6 zeros. 8 million. Okay. When you write a number as the product of a number and the power of 10, you are using scientific notation. Scientific notation is a useful way to write large and small numbers. Many calculators display numbers 1 billion or larger with scientific notation. In scientific notation, 4,000 is written as 4 times 10 to the power of 3. It is read as 4 times 10 to the third power. Either way, 10 to the power of 3, 10 to the third power means the same thing. Okay, so let's write each of these numbers in standard notation and then practice writing them in number word notation. So 5 times 10 to the power of 3, 5 times 1,000, 5,000, and I would say 5 and the word 1,000 for number word. 7 times 10 to the power of 2, 7 times 100, 700. Oops, I almost wrote an S. 700. 2 times 10 to the power of 4. 2 times 10,000. So 20,000. And I would write 20, since my number word is 1,000. So I'm writing the numeral and the place value becomes the word. What period basically becomes the word. Okay, so I have 5 times 10 to the power of 6, 5 times 1 million. So I have 5 million. Okay, and the number 5 and the word million. All right, what's my big idea? So we use number word notation to write large numbers. We use powers of 10 to help you write large numbers. And scientific notation is another way to write large and small numbers. Okay, so that's it, and all you need to really focus in on is each of those 3 ideas. There are There are a number of different ways of renaming numbers as you start to use larger and larger numbers. Okay? All right. I'll see you in class.